Alright guys, so I apologize. I tried to film this video and upload it, but when I went to upload it, we struggled. Alright, so we're gonna go ahead and film it again because the video did not have, it only had audio. So I'm gonna look at number 1 with the study guide and we'll begin there, okay? Unit 3 study guide. So if you guys have your study guides, you can follow along. Alright, so number 1, it says the sum of 5 and a number x. So my suggestion to you, and remember my suggestions are only to help you succeed. So if you guys ever see an algebraic expression, meaning you need to write it in an algebraic expression, take words and put them into numbers, we're going to look at the terms, okay, and the operations. You're going to have 3 parts: something, some term, an operation, and another term. Okay, so the problem reads the sum of 5 and a number x. Okay, it says 5, that's our first term, and a number which we represent with x. Okay, so we have 4 operations. We can have addition, subtraction, multiplication, or division. Now there's a key word in our problem that says sum. Sum actually means addition. So our operation for this expression would be plus, right? Addition. So my answer would actually be 5 plus x. All right, so that was number 1. Okay, number 2, guys, it's basically the same thing as number 1. However, you have a different keyword, right? So again, I'm going to set it up. I've got the product of 11 and a number z. So my first term is 11, and my second term is some number, which we can represent as z. All right, and then it says product. Product is the key word that means multiplication, so I can write a multiplication sign. Now we talked about having a number times a letter, and there's another way we can write this. Okay, 11z. Just be more familiar with this form because that's how you'll see it, right guys? Because we call that 11 the coefficient. Nice job, okay? So let's move on to number 3. Number 3 says Miss Dolinsky plans to make 2 bracelets for each student in her homeroom. If she has an X amount of students in her homeroom, write an algebraic expression for how many bracelets she would make. Now, you could think about this one of 2 ways, okay? So the first way, you could think, okay, I have 2 bracelets for 1 student. I'm going to have to add another 2 bracelets for another student, and so on, right? However, do we know how many students are in the class? No, we don't. So we represent that number, which is the amount of students in the class, with an x, right? So the way we can write this, remember we talked about repeated addition. You could say 2 plus 2 plus 2 plus 2 plus 2, but we don't know how many students, right? So repeated addition we say is multiplication. So we could take 2 times the amount of students, and in this case we don't know how many, and that would be 2x. So my answer would actually be 2x, right? 2 times the amount of students that are in the class, which we don't know. All right, so let's move on to number 4. It says Juan scored 15 goals during this soccer season. Now, that first sentence doesn't really tell us anything other than how much Juan scored, right? And that's 15. Juan scored 15 goals. Now, the second sentence is actually our algebraic expression. It says Angie scored n fewer goals than Juan. Now, it says Angie scored n fewer goals. Do we know how much Angie scored? No. So that we're going to represent with an n. Okay, fewer than means subtraction, then Juan, which Juan scored 15 goals, okay? So Angie scored n fewer goals than Juan, and Juan scored 15 goals. All right, however, our key word, remember, your brain should be going ding, ding, ding. I know that fewer than actually is a turnaround word, right? Just like greater than, more than, less than. Those are all turnaround words. By turnaround, we mean we're gonna take the first term and flip it with the second term. So my actual answer would be 15 minus n. Okay? All right, moving on to number 5. It says Mike and his sister Susie collect seashells when they visit the beach. Susie has half the amount of seashells as Mike. If Mike has X number of seashells, write an expression for how many seashells Susie has. Wow, that's a tongue twister. All right, number 5. Now, here's your key word with this sentence, guys. If you ever see some amount as many as somebody else, or for example, the question says half the amount as Mike, that's a multiplication expression, meaning we're going to write that representing multiplication. Because what if Susie had twice the amount of seashells as Mike? We would write 2x, right? Because we don't know how much Mike has. We could say 2 times x. In this case, we have a fraction. She has half the amount. So we could say 1/2 x, or we could say x divided by 2. All right, these actually mean the same thing. So both answers are correct, and I'll show you why. What if we said Mike had 8 seashells? If I plug that in, 1/2 times 8 would give me 8 over 2, which simplifies to 4. That's how many Susie would have. If we use that expression and plug in how much Mike would have, theoretically, we're saying 8, Susie would still have 4. So these two expressions are the same thing. So either 1/2 x or x over 2 would be an appropriate answer. All right, so let's move on to number 6. Number 6 says, Mrs. Spare is having sprinklers installed in her yard. The sprinkler company charges $65 for the visit, so they automatically charge $65. They're going to charge also $45 per hour. So $65 plus $45 for each hour of work. That means if they work for 1 hour, they make $45. Okay, well, they'll charge. If they work for another hour, they'll make another $45, right? So this is for each hour. Okay, but we don't know how many hours they're working, so we can represent that with an X. This looks a lot like number 3, right? We don't know the amount of students, but we know how many bracelets each student would get. So if we look at number 6, again, we don't know the amount of hours, but we know how much this company charges per hour. So the way we can represent this is 45 times X. So my expression would be 65 plus 45x for that problem. Okay? All right, number 7. I'm going to flip to a new page. So number seven, I'm sorry, tongue twister, is actually really simple if you guys just follow order of operations. And this is my suggestion. Again, it is only my suggestion. If you refuse not to follow it, that's up to you. I would write PEMDAS, okay, right off to the side, and I would actually check mark when you're done or there's nothing present to evaluate. So I'm going to start with P, parentheses. I've got a 3 in the parentheses, but it's just a 3. There's not much I can do there, so I'm going to check that off because it's already a 3. There's nothing to evaluate. All right, next is exponents. I actually do have an exponent of 3, and that actually is applied to the 3 inside the parentheses. So that means it now becomes 6 times 3 times 3 times 3. So now I've taken care of my exponents, right? Now I come to the groups, multiplication, division, addition, subtraction. And I say groups because we read left to right. So whatever of these groups comes first, left to right, is what I would evaluate. Same for addition, subtraction. So multiplication, I don't have any division, so that's done. I'm going to go ahead and do multiplication, left to right. Okay, so 6 times 3 is 18, times 3 times 3. Notice how I'm rewriting. I'm not evaluating anything. I'm just going to rewrite step by step. Okay, now I've got 18 times 3. I'm going to say that's 54. Let's double check. 18 times 3. Yep, 54 times your 3. And then I believe that is 162. Yes, 162. So my answer would be 162 for number 7. All right, so number 8, again, that's the same strategy of thinking of evaluating one thing at a time. Okay, so I'm going to rewrite it on my paper. All right, I've got 2x plus 3y squared minus 4z. And then it tells me that x is equal to 3, y is equal to 2, and z is equal to 4. Now, whenever I have a problem like this, guys, I should automatically, just by context clues, is by seeing if there's a number or a letter and it's equal to a number, that means I'm going to substitute for every letter that number. So I'm going to go ahead and just substitute. Remember, just do step by step. So I'm taking all of these and substituting for the letters. And remember, we said if it's a number next to a letter, so coefficient next to a variable, we are going to multiply them. So 2 times 3 plus 3 times y, which is 2, squared. Now remember that 2, the squared is attached to the 2, not the 3. Okay? Minus 4 times z, which is 4. Now, again, just like number 7, I'm going to go ahead and write PEMDAS off to the side because now it's an order of operations problem. Parentheses, nope. Exponents, yep. So I'm going to go ahead and expand that. Alright, so exponents is done. Now my groups, multiplication, division, addition, subtraction. So I don't have any division, that's done. I do have multiplication though. So I'm going to read left to right and do one thing at a time. Alright, I do have another set of multiplication. And one last, oopsies, Ms. Donsky, you wrote it wrong. Last multiplication right here. Alright, I'm going to rewrite it. Alright, now I'm done with multiplication division and move on to addition subtraction. Okay, so I'm going to add first because it's on my left side, and I get 18 minus 16. Lastly, I'm left with subtraction, and my answer is 2. Alright? Alright, guys, so I'm actually going to do 9, 10, 11, 13, 15, 17, and 19, and you can do the right half on your own because these are the same types of problems. Alright, so number 11. Number 11 says write the following expressions using exponents. Exponents we know are like 2 squared, 4 cubed, right? So I'm going to rewrite my problem. Alright, and we're going to look at this. There's a few things that I notice. These 4s are being multiplied, and then they're being added to these 6s that are being multiplied. Now remember, we said repeated addition is multiplication. However, if repeated multiplication is shown, I can write that in exponent form. So my base here would be 4, and then how many times are we multiplying 4 by itself? 4 times. That would be my exponent. We only write in exponential form if they're being multiplied together, okay? Here, we would not write in exponential form because that's an addition, so I'm just going to add that to 6 times 6 times 6, which this is being multiplied just like these 4s, so I can write that in exponential form. My base is 6, and the amount of times I'm multiplying it is 3, so that's my exponent. This is my answer. I would not solve because the question only says write in exponent form, and my answer is in exponent form. Okay, so I'm going to move on to number 13. Again, I skipped 12 because it's a lot like number 11. All right. All right, I'm going to rewrite it. All right, so the question says simplify the following expression and name the parts. So there's 2 things we do to simplify the expression, right? Number 1, we distribute. And number 2, we combine like terms. So let's look at number 1. Is there anything we can distribute here? Yes, there is. So I'm going to go ahead and distribute that. So I can distribute 2 to x and 2 to y to get 2x plus 2y. And then I'm going to rewrite this part, plus x plus 4y plus 6. And then notice here, 3 parentheses, 4 parentheses. That means multiplication, so I can distribute 3 to 4 as well to get plus 12. right? So now I've distributed successfully, and next I need to combine my terms. So guys, you can use shapes, you can use colors. I like to use shapes, so I'm gonna shape out anything else that has an X. So I'm gonna give a circle to 2X. So anything with an X, just one X, right, is what I'll combine. So I've got 2X and another X here. Remember we talked about the implied coefficient of one letter would be 1. So 2 plus 1 gives you 3, and they're X's, so 3 X's. I'm going to give Y's a different shape. I've got 2 Y's plus another 4 Y's, right? We're only adding the coefficients. The variables stay the same. So 2 plus 4 is 6. So plus 6, and those were both Y's. And now I'm left with my constants. Very good. 6 plus 12 gives you 18. So this is my simplified expression, right? Now the question says we need to label the parts of the expression. Now, we've got terms, we've got coefficients, we've got constants, we've got variables, and we've got exponents. Now, some of these may not have them, and that's okay. But what I want you to remember with these, when we label the parts of the expression, it's never going to be the original expression. It will always be your simplified expression. Think that all that hard work that you did to distribute and combine, now we're going to use that hard work, right? So this is the answer we're going to use to label the parts of the expression. All right, so terms, we said that terms are separated by a plus or minus sign. So I've got 3x, 6y, and 18. I'm going to write them down here. 3x, comma, 6y, comma, 18. So those are my 3 terms, right? Now I've got coefficients. Remember we said coefficients are the numbers in front of a variable. So we've got 3 and 6. So I'm going to go ahead and represent that with a comma. So 3, comma, 6. 18 would not be a coefficient because it's not attached to a variable. That's actually a constant, which leads us to the next piece. All right, so if I look at 18, 18 is actually a constant. So let me color code these for you guys. So 18 is my constant. And next I've got variables. Variables are the letters. So the only letters I see are X and Y. Oh, that's kind of dark, sorry. X and Y. And remember, when we're writing coefficients or variables, we don't ever write the coefficient with 3x and 6y because that's now wrong. Coefficients is literally just the number in front of the letter. And the variables, same thing, you're just writing your letters, okay? It's kind of like breaking down the expression. And our exponents, we don't have any, so we're going to say none. All right? So that's how you do those types of questions. Number 14 is exactly like number 13. So I'm going to move on. Number 15, it says, I'm going to go ahead and draw this. Oops. But before I move to 15, let me make a quick note about number